Hello student, in previous class I discussed about different types of stoichiometry calculation. In the previous class I discussed about the mole-mole relationship, and I have also carried out some problems related to the mole-mole relationship. Next, second, I have also covered about the relationship. Next, I also covered some problem related to the mass relationship, and I also covered the mass volume relationship. These are some problems. Next, finally, I covered the volume relationship, and these are the few problems. In the previous class, I covered the totally stoichiometry calculation. In this class, I will explain a new concept, that is laws of chemical combination. That is your laws of chemical combination. The laws of chemical combination includes different laws. First law is law of conservation of mass. It is also called laws of indestructibility of matter. Second is a law of definite or constant proportion, or Proust law, or law of definite composition. Next law is law of multiple proportion. Next law is law of reciprocal proportion. Next last law is the law of gaseous volume, that is the law of combining volume. These five laws are very important for this chapter. Generally, a question will always ask in the exam. So let me explain the first law. That at first I will discuss about the law of conservation of mass. That is also called law of indestructibility of matter. Let me explain what is the statement of the law. In all physical and chemical changes, remember, in all physical and chemical changes, the total mass of a system remain constant, or in a chemical or physical change, mass is neither created nor destroyed. Simply, here you can say that in a complete reaction, the total mass of the reactant is equal to the total mass of the product. It is the indirect statement. Suppose I want to take a reaction. Let me explain this example. On heating, 100 gram of mercury oxide undergoes decomposition to yield 92.6 gram of mercury and 7.4 gram of oxygen, so that the mass is conserved during chemical reaction. As per the statement of the law of conservation of mass, here we can say that for a complete reaction, total mass of the reactant is equal to total mass of the product. Suppose I will take a reaction, X gives Y. Suppose X amount of X I have taken is your 100 gram. Obviously, the amount of Y produced is also 100 gram. Suppose I will take another example, X plus Y gives Z. This is a suppose complete reaction. Then we can say that the weight of X plus the weight of Y is equal to the weight of Z. Suppose it is an incomplete reaction. Some parts of the reactants are remained. They do not undergo the reaction. Suppose I have taken this is your 100 gram of X, 100 gram of that is your Y. Suppose 90 gram of X is consumed, 90 gram of Y is also consumed. Then what will be the relationship? What here suppose Z is your 180 gram. Here Z is your 180 gram. Then what will be the formula? Total mass of the reactant, that is your 100 gram plus 100 gram, is equal to total mass of the product, that is your 180 gram, plus total mass of the on reacted reactant, that is your 10 gram of X is remained this 10 gram do not undergoes reaction. Here also 10 gram of Y does not undergoes reactions. So here I can say that 180 sorry, the total mass of the reactant is your how much? That is your 100 plus 100 is equal to 180 plus 20. Remember, here I can say that for a complete reaction, suppose a reaction is completed, all the reactants are converted into products, then in that case I can say that total mass of the reactant is equal to the total mass of the product. But for an incomplete reaction, suppose some parts of the reactant are present, they do not undergo the reaction, then what will be the form? What is the formula? The total mass of the reactant is equal to total mass of the product plus total mass of the unreacted reactant. All chemical law follows this law. All chemical reaction follow this law. Law of conservation of mass is always satisfied in all chemical reaction. So here we can here we can say that again. I want to repeat this. What is the statement? In all physical and chemical chain, the total mass of the system remain constant. Look at that here. The total mass of the reactant, that is your remain constant. Here the total mass of the product also remain constant. Or in a chemical or physical chain, mass is neither created nor destroyed. Here no new new mass is created. Here no mass is lost. So this is called law of conservation of mass. Since there is no creation of any mass, no destruction of any mass, so the total mass is conserved, the total mass remain constant. So this is called law of conservation of mass. Look at an example. Take an example. On heating 100 gram of mercury. Here, 100 gram of mercury is taken, and this undergoes decomposition to yield 92.6 gram of mercury and 7.4 gram of oxygen. Now prove that this chemical reaction follow law of conservation of mass. That is your mass is conserved during the chemical reaction. Here I can say that mercury oxide undergoes reaction gives mercury plus oxygen. Now experimentally it is in that 100 gram of mercury, here 100 gram of mercury is given. So here I can say that 100 gram of mercury oxide. Here 100 gram of mercury oxide is given. So here I have written 100 gram. Next, what amount of mercury? That is your 92.6 gram. What amount of oxygen? That is your 7.4 gram. Look at that. If you want to think about the total mass of the reactant, then how much? That is your total mass of the reactant means here total mass of the mercury oxide. Here the total mass of the mercury oxide is your 100 gram. So I have written here the total mass of the reactant is your how much? 100 gram. Now look at me the total mass of the product. Total mass of the product means total mass of the oxygen plus total mass of the mercury. So here you can say that total mass of the product is equal to 92.6 plus 7.4, that is your 100 gram. Look at that, the total amount of the reactant is your 100 gram. The total amount of product is also 100 gram. So here I can say that the total amount of the reactant is equal to the total amount of the product. Since here total amount of the reactant is equal to total amount of the product, so the law of conservation of mass is verified. Here no mass is created, no mass is destroyed. So here we can say that law of conservation of mass is verified. Law of conservation of mass is proved. Note part some important points. Again I will repeat, for complete reaction, total mass of the reactant is equal to total mass of the product. For incomplete reaction, total mass of the reactant is equal to total mass of the product plus total mass of the unreacted reactant. Next, all chemical reaction follow this law. If reaction do not follow law of conservation of mass, then remember this chemical equation is invalid. This chemical reaction is impossible. So all chemical reaction must follow law of conservation of mass. Next, I want to see some problem related to this type of law. Look at me. This is a problem number 1. Let me explain how I will solve this. What mass of sodium chloride? Look at that question. Again, I want to repeat. What mass of sodium chloride would be decomposed by 9.8 gram of sulfuric acid if 12 gram of sodium bisulfate and 2.7 gram of hydrogen chloride were produced in a reaction, assuming that the law of conservation mass is true. Here law of conservation, look at that, here an important point is given, that is your law of conservation of mass is true. True means law of conservation of mass is satisfied to this chemical reaction. So here I can say that for a complete reaction, total mass of reactant, total mass of the reactant is equal to total mass of product. Total mass of the reactant is equal to how much? Total mass of the product. This is the main concept. Since this chemical equation obey law of conservation of mass, means you can directly write down total mass of the reactant is equal to total mass of the product. Let me find the solution. Suppose x gram of sodium chloride is decomposed. Here the mass of sodium chloride is not given, but here for solution I can take let mass of sodium chloride is your x gram. Now I want to write a balanced chemical equation. Look at that. Here sodium chloride undergoes decomposition by sulfuric acid. That means here I can write sodium chloride, that is your NaCl, and sulfuric acid means H2SO4. So the reactant must be your NaCl plus H2SO4. Now look at again, read the question. If 12 gram of sodium bisulfate and 2.7 gram of hydrochloride were produced, that means here the product is your sodium bisulfate and another is your hydrogen chloride. So here I can write NaHSO4. This is the formula of sodium bisulfate, that is your sodium hydrogen sulfate. That amount is 12 grams. So I have written here 12 gram. Here H2SO4 is 9.8 gram. So I have written 9.8 gram on the bottom of the H2SO4. Here x gram of sodium chloride is taken as let. So here I can write x gram. Look at that. 2.7 gram of hydrogen chloride were produced. So here I have written plus HCl and 2.75 gram of HCl is produced. So I have written in the bottom of HCl, that is your 2.75 gram. Look at that, here NaCl H2SO4 belongs to the reactant, and NaHSO4, that is your sodium bisulfate, and HCl are belong to the products. So the total mass of the reactant, I can here say that total total mass of reactant means here I can say that to mass of NaCl plus mass of H2SO4. So here I can write, according to law of conservation of mass, total mass of the reactant is equal to total mass of the product. Total mass of the reactant means here I can write x mass of sodium chloride is taken as x, it is considered as let. Mass of hydrogen sulfate, hydrogen sulfuric acid, sulfuric acid means that is your 9.8 grams. So here I can write x plus 9.8 gram. This is the total mass of the reactant. So here I can write here x plus 9.8 is equal to total mass of the reactant. Next, total mass of the product means here I can say that total mass of the product means what? I can write here That is your mass or total mass of NaHSO4 plus total mass of HCl. Here the total mass of NaHSO4 is equal 12 gram. So here I can write 12 gram plus total mass of HCl is your 2.75 gram. So here I have written 12 plus 2.75 gram. Now I can solve this. X is equal to how much? 12 plus 2.75 is equal to 14.75. Now change the position of 9.8 from left to right. So here plus 9.8 is given. So here I can write minus 9.8. So x is equal to how much? 14.75 minus 9.8. After subtraction, here I can say that x is equal to 4.95 gram. So here I can say that mass of sodium chloride is your 4.95 gram. That means 4.95 gram of sodium chloride is decomposed by 9.8 gram of sulfuric acid, then 12 gram of sodium bisulfate, and 2.7 gram of hydrogen chloride were produced. This is problem number 1. Let's move to the problem number 3. Problem number 2. What is the problem number? Same type of problem, just like problem number 1. Look at that. Here methane react with the chlorine. 16 when 16 gram of methane react with the chlorine, that means here the reactant is your methane, another is your chlorine. Then 40.5 gram of methyl chloride, this is the product, and 36.5 gram of HCl form. That means here the first product is your methyl chloride, and the amount is your 40.5 gram, and the second product is your HCl, and the amount is your 36.5 gram. Here the reactant is your, one is your methane, another is your chlorine. Here the reactant methane, the amount of methane is your 16 gram, and the amount of chlorine is not given. Our target to find out the amount of chlorine. So let mass of chlorine is your x gram, and the equation is your what? Here CH4 plus Cl2 gives CH3Cl plus HCl. Here the reactant are means one is your CH4, another is your Cl2. So here I can write total mass of reactant equal to mass of CH4 plus mass of chlorine. Mass of the CH4 means how much? 16 gram. Here I have written 16 gram, x gram, 40.5 gram, 36.5 gram. I have written the weight of each species. So here I can say that mass of CH4 is your 16 gram, mass of chlorine is your x gram. So here I can write 16 plus x. So here look at that. Here I can write according to law of conservation mass, total mass of the reactant is equal to total mass of the product. So I have written here 16 plus x, that is the total mass of the reactant. Look at the total mass of the product. Here the product are methyl chloride, another is your HCl. So here I can say the total mass of product is equal to, what is the formula? Mass of CH3Cl plus mass of HCl. Mass of CH3Cl means how much? That is your 40.5 gram, and mass of HCl is your 36.5 gram. So here I can write again, return to the equation. 16 plus x is equal to 40.5 plus 36.5. If you add 40.5 plus 36.5, then that's equal to 77. So here I can write, change the position of 16 from left to right. Here plus 16 is given, here minus 16 is written in the right side. So here I can say that x is equal to 17 minus 16. X is equal to how much? That is your 61 gram. So here I can say that mass of chlorine is your 61 gram. Next move to the problem number 3. Just they are just similar to each other. Now I will just change the problem. In all the case, law of conservation mass is satisfied. Here actually in problem number 2 there is a slightly mistake. Here it is not necessary to write this equation satisfied the law of conservation. I will correct when I will give the PDF. I will correct this question. Actually, here there must be a sentence that is your this equation, this chemical reaction obey the law of conservation of mass, like this question. Look at that here. A sentence is written that is assuming that the law of conservation mass is true. Like problem number 1, here also there is a need to write such type of sentence. Look at that. In problem number 3, it is quite different. Here your target to prove law of conservation mass is verified. In problem number 1 and 2, already law of conservation mass is verified and your target to find out any species. But here look at that, all the species weight are given. Your target to prove this chemical equation satisfy the law of conservation of mass. This is different. Look at that. A 0.22 gram of sample of hydrocarbon containing only carbon and hydrogen was completely born in 1.12 gram of oxygen. Look at that. Again, I want to read a 0.22 gram of sample of hydrocarbon contain only carbon and hydrogen was completely bound into 1.12 gram of oxygen. Here, look at that. Here, hydrocarbon is the reactant and oxygen is also another reactant. Look at that. In hydrocarbon, there is no oxygen is present. So the product formed here, that is your carbon dioxide and water, is completely depend upon the oxygen provided as the reactant. All the oxygens are completely comes from the oxygen gas. Since hydrocarbon have no carbon elements, the hydrocarbon is only made by carbon and hydrogen. If a organic compound is given in which oxygen is present, then you cannot say that all the oxygen present in carbon dioxide and water are comes from oxygen molecule. Some oxygen may comes from the organic compound, because the organic compound contain oxygen. But look at that, here hydrocarbon is given, so here a word is written on the sample of hydrocarbon contain only carbon and hydrogen. Here no oxygen is present, so you cannot say that the carbon dioxide produced here the carbon dioxide and water produced as a product do not related in terms of oxygen with the hydrocarbon. They only comes from the oxygen gas separately given. So here again I want to read the question. A 0.2 gram of sample of hydrocarbon contain only carbon and hydrogen was completely bound in 1.12 gram of oxygen. That means here I can say that hydrocarbon is the main reactant and oxygen is the other reactant. And look at again, read the question. The combustion produces 0.9 gram of water and 0.44 gram of carbon dioxide. That means here the product is your one is your water, another is your carbon dioxide. Your target to show that the result are in accordance with the law of conservation of mass. That means your target to prove law of conservation mass is verified. For proving the law of conservation of mass verification, you need a term, that is your total mass of reactant. Total mass of the reactant is equal to total mass of product. If I will prove, if I will prove total mass of reactant is equal to total mass of the product, then finally we can write, since here total mass of the reactant is equal to total mass of the product, so the law of conservation of mass is verified. If the total mass of the reactant is not equal to total mass of the product, I cannot say that the law of conservation of mass is verified. So our target to find out the total mass of the reactant and also find out the total mass of the product and verify whether the total mass of the reactant is equal to the total mass of the product. From the question here I can write the equation like this: hydrocarbon plus oxygen gives carbon dioxide plus water. From the question here I can say that what is the weight of the hydrocarbon? The weight of the hydrocarbon is your how much? 0.22 gram. And the weight of oxygen is your how much? 1.12 gram. So here I can write 0.22 gram. In the bottom of oxygen I can write 1.12 gram. These two are said to be reactant. Next, move to the product. Here carbon dioxide and water is formed. What amount of carbon dioxide is formed? That is your 0.44 gram. What amount of water is formed? That is your 0.9 gram. So here I can write in the bottom of the carbon dioxide, here I can write 0.44 gram. In the bottom of water I can write here 0.9 gram. Look at that. Your hydrocarbon and oxygen are considered as the total mass of your hydrogen and oxygen are considered as the reactant. Carbon dioxide and water are treated as the product. So here I can say that total mass of the reactant. Total mass of the reactant means weight of the hydrocarbon plus weight of the oxygen. Your weight of hydrocarbon means 0.22 gram. So here I can write equal to 0.22 plus what amount of oxygen is used? That is your 1.12. So here I can write 1.12. So here I can say the total mass of the reactant is equal to 0.22 plus 1.12. If you will add both, then 1.34 gram of the reactant is produced. Now see the total mass of the product. Total mass of the product means see, here I can say that here the sentence is wrong. Your total mass of the product means see, here I can say that weight of, here I can say that weight of carbon dioxide plus weight of water. This is the this is the total mass of the product. Weight of carbon dioxide is your 0.44. Weight of water is your 0.9. If you want to add 0.44 plus 0.9, then you will find 1.34. Look at that. Here the total mass of the reactant is your 1.34 gram. Total mass of the product is also 1.34 gram. That means here I can say that total mass of the reactant is equal to total mass of the product. Since the amount of the reactant equal to the amount of product, so the law of conservation, law of conservation of mass is verified. This is problem number 3. Next, move to the problem number 4. Look at that. Here slightly some mistakes, so I will rectify later. Now move to the problem number 4. Look at that. If 12.6 gram of sodium bicarbonate is added to 20 gram of HCl solution, then the resulting weight of then the resulting solution weight is your 24 gram. What is the mass of carbon dioxide in the reaction? This is the question. Here the mass of the carbon dioxide. Your reaction is consider. Look at that. I want to write the reaction first, then I want to proceed further towards next step. Look at that. Here 12.6 gram of sodium bicarbonate is given. Here I can write NaHCO3. Look at that, plus HCl. This is the reactant. NaHCO3 is the one reactant and HCl is the second reactant, because 12.6 gram of NaHCO3 is added. Here added is given to 20 gram of HCl solution. So here HCl and NaHCO3 are the two reactant. Here the weight of NHCO3 is your 12.6 gram. Here the weight of HCl is your 20 gram. They undergoes reaction, form a solution. But according to the question here, I can write a solution. Plus what happened? Carbon dioxide is formed also. So here I can write CO2. Here the weight of the solution is your 24 gram. Your target to find out the weight of carbon dioxide. Again here there is here also something missing. Here also in problem number it is highly necessary to write such type of sentence. Assuming the law of conservation mass is verified. Here also same problem. I will change later. Look at that. Oh, suppose you think that this equation obey the law of conservation. Think that the reaction obey law of conservation of mass. If the reaction obey the law of conservation of mass, here we can say that total mass of the reactant, total mass of reactant equal to what? Total mass of product. Here the total mass of reactant means NaCO3 plus HCl. Total mass of product means solution, weight of solution plus carbon dioxide. Look at that. Here given mass of NaCO3 is your 12.6 gram, mass of HCl solution is your 20 gram, mass of resulting solution is your 24 gram, mass of carbon dioxide is your our aim to find. You will take x gram as your choice. You will solve in different way. Here we can say the total mass of the reactant. Total mass of the reactant here I can say that 12.6 plus 20. That is your 32.6 gram. Total mass of the reactant is your 32.6 gram. Total mass of the product means mass of the resulting solution plus mass of carbon dioxide. So here I can say that mass of the resulting solution is your 24 gram. So here I can write 24 plus mass of carbon dioxide. This is your carbon dioxide, not carbon monoxide. This is your carbon dioxide. According to the law of conservation mass, total mass of the reactant is equal to total mass of the product. So here I can say that 32.6. This is the total mass of the reactant. So here I can write 32.6 is equal to 24.0 plus mass of carbon dioxide. This is not carbon monoxide. This is a carbon dioxide. So here I can say that mass of carbon dioxide is equal to 32.6 minus 24. So here again I say that I can say that mass of carbon dioxide is your 8.6. So that mass of carbon dioxide produced during this reaction is your 8.6 gram. This is the answer. Next, I want to move to the next second law, that is law of definite or constant proportion, or that is called Purston law or law of definite composition. Look at that. It is very interesting to understand. Try to I want to let me explain. Again, I want to explain clearly. Look at that. Before going to the statement, at first I want to speak something about this explanation. Look at that. There are three equations are given. This is first equation. This is second equation. This is a third equation. Our target to find out the carbon dioxide. Main target is to prepare the carbon dioxide. This is the first method of preparation for carbon dioxide. This is the second method of preparation for carbon dioxide. This is the third method for preparation of carbon dioxide. In the first method, what happened? I have taken the calcium carbonate. And subjected to heating. Then it gives calcium oxide and also carbon dioxide. Here carbon dioxide is formed by heating the calcium carbonate. In the second method, what happened? I have taken directly carbon and oxygen and combined the carbon and oxygen, then carbon dioxide is formed. Here the carbon dioxide is formed from the corresponding element, that is a carbon and oxygen. This is the second method of preparation for carbon dioxide. Look at the third. Here carbon dioxide is also formed, but it is formed when calcium carbonate undergoes reaction with HCl. In the third method, calcium carbonate undergoes reaction with HCl, then calcium chloride and water and carbon dioxide is formed. What happened in I have taken a target to prepare carbon dioxide. For preparation of carbon dioxide, I have chosen three methods. First method, that related to the calcium carbonate. Calcium carbonate undergoes heating, gives calcium oxide and carbon dioxide. In the second method, here also carbon dioxide is formed from carbon and oxygen. In the third method, calcium carbonate undergoes reaction with HCl. In the first step, calcium carbonate undergoes heating, but here the calcium carbonate and HCl are undergoes reaction with each other, form the carbon dioxide. Suppose I want to find a ratio. If I want to find out the carbon dioxide prepared by method 1, that is a method I. If you think about the method I and think about the carbon dioxide prepared from method 1, look at that. If you I want to say that in this case, if you take a ratio of the weight of the carbon and oxygen, then look at that. The ratio must be taken by mass. Here the atomic mass of carbon is 12. Look at that. Here the atomic mass of carbon is 12. Here the mass of oxygen molecule. Here molecular mass is taken because two oxygen atom is present. So atomic mass of oxygen is your 16 gram. If you think about the molecular mass, that is your 32. That means here we can say that the ratio for the carbon dioxide prepared from the first method. If you think about the ratio of the carbon and oxygen, here you can say that 12 is to 32. Now simplify this. Here we can divide by, that is your suppose 4. If you divide by 4, then it here 3, here 8. So here you can say that 3 is to 8. And I am thinking about this carbon dioxide. In this I am thinking about the carbon dioxide prepared by using the first method. In the first method, the carbon dioxide produced, no doubt carbon dioxide is produced, and it have a ratio that maintain, that is a ratio of carbon and oxygen is a 3 is to 1. In the first method, carbon dioxide is formed from calcium carbonate. If you want to check the ratio of carbon and oxygen in carbon dioxide molecule, then the ratio is your 3 is to 8. Clear? Now move to the second method. The carbon dioxide. Think about the carbon dioxide produced by second method. Here carbon dioxide is produced directly combination of carbon and oxygen. If you want to think about the carbon dioxide prepared by using second method, look at that. Now find the ratio between carbon and oxygen. Here we can also find the ratio, that is your 12 is to 32. Here we can say that 3 is to 8. Now think about the carbon dioxide prepared by using method 3. The carbon dioxide in method 3 is prepared by the reaction between calcium carbonate and HCl. Look at that. Here, if you think about the carbon dioxide, if you find out the ratio of carbon and oxygen, then the ratio is also 12 is to 32. That is your 3 is to 8. Suppose you will use the fourth method and carbon dioxide is formed. This carbon dioxide also maintain the ratio 3 is to 8. You can use any type of method. for the preparation of carbon dioxide. The carbon dioxide formed in each method must maintain the ratio, that is a 3 is to 8 by mass. That means every carbon dioxide produced from different method maintain have a constant ratio, that is a 3 is to 8. So now I want to go to the statement. Look at that. A chemical compound. Suppose I want to think about the carbon dioxide. Suppose you can take any other chemical compound, but suppose I want to think about the carbon dioxide. A chemical compound, that is your carbon dioxide, always contain the same element. Look at that. In the first method, this carbon dioxide carry carbon and oxygen, one carbon, two oxygen. In the second method, this carbon dioxide also carry one carbon, two oxygen atom. In the third method, this carbon dioxide also carry one carbon, two oxygen. So here I can say that carbon dioxide. Here I can say that carbon dioxide always contain the same element, that is your carbon and oxygen, and these elements combined in a fixed proportion by mass, that is your 3 is to 8. That is your 3 is to 8. If you will change this ratio, then you cannot find the carbon dioxide. It changes to any another chemical compound. So carbon dioxide means 3 is to 8 by mass. According to mass, the ratio is a 3 is to 8. If you change this ratio, then you unable to find the carbon dioxide. You may get any other chemical compound, but you do not get the carbon dioxide. So a chemical compound, that is your carbon dioxide, always contain the same element, combined in a fixed proportion by mass. Look at the example. Your carbon dioxide I have given. That is a chemical compound has a fixed composition. Obviously, your carbon for the preparation of carbon dioxide, you will take one carbon, two oxygen, and you must maintain the ratio, that is your 3 is to 8. And it does not depend on any method. Obviously, the composition of carbon dioxide does not depend upon the any method for the during the preparation. The carbon dioxide always carry one carbon, two oxygen, and maintain 3 is to 8, 3 is to 8 ratio. Whether you will prepare from calcium carbonate, or you will prepare that combination carbon and oxygen, or you will prepare the reaction between calcium carbonate and HCl. The carbon dioxide always have the same element. They have a fixed proportion, and they have a fixed composition. They do not depend upon the method. Okay, this is said to be law of definite or constant proportion. Here proportion is constant. Here the product composition is definite. It is proposed by Purshot. It is proposed by Purusht, and it have definite composition. That is a law of definite composition. So here we can say that I want to again repeat the statement. A chemical compound always contains same element combined in a fixed proportion by mass. That is, a chemical compound has a fixed composition, and it does not depend on the method of its preparation or the source from which it has been obtained. This is the explanation. Now move to the problem. Look at the problem carefully. Then you will able to find the solution. Look at that. 1.75 gram of copper oxide gave 1.09 gram of copper when reduced with a hydrogen current. That means here a experimental method is given for the. Look at that. Here copper oxide gave copper when reduced with. That means here copper oxide is treated with hydrogen gives copper, gives copper. This is the main target. Another byproduct you will form also water. You can form water. Look at that. Here two experimental method is given. In the first experimental method, I have taken 1.375 gram of copper oxide and reduced with the hydrogen. Then I will get 1.098 gram of copper. So here in the first experiment, I can write weight of copper oxide, that is your 1.375 gram. Weight of copper is your how much? That is your 1.098 gram. In this problem also second experimental method is also given. Look at that. In the other method, in the other experiment, 1.47 gram of copper oxide gave 1.179 gram of copper on reduction. That means here I can write in the second, for a second experiment I can write here, weight of copper oxide is your how much? 1.47 gram of copper, and weight of copper is your 1.179 gram of copper. Look at that. Here, if you want to think about the decomposition of copper oxide, look at that. Here, copper in the first experiment, copper oxide. Think about the copper oxide. In the second experiment, also think about the copper oxide. Here, the weight are different. If I will take 1.75 gram of copper oxide, then 1.098 gram of copper is produced. But in the second experiment, if you will take 1.47 gram of copper oxide, then you will able to find 1.179 gram. Think about the copper oxide in both the case and find out the percentage of copper and percentage of oxygen. There are two experiments. Look at that. If the percentage of copper in the first experiment is equal to the percentage of copper in the second experiment, similarly, if the percentage of oxygen in the first experiment is equal to in the percentage of oxygen in the second experiment, then here we can say that in the first experiment, the percentage of copper is equal to the percentage of copper in second experiment. So in the if you think about the oxygen, the percentage, if the percentage of oxygen in the first experiment is equal to the percentage of oxygen in the second experiment, then here you can say that in first experiment the composition of copper is most equal to the composition of copper. Sorry, you can say that finally you can say that the composition of copper oxide in the first experiment is equal to the composition of the copper oxide in the second experiment. Again, I want to repeat, if you will prove the percentage of copper is equal to, if you will prove the percentage of copper in the first experiment is equal to the percentage of copper in the second experiment, and simultaneously if you will prove percentage of oxygen in the first experiment is equal to the percentage of oxygen in the second experiment, then you can say that the copper oxide used in the first experiment having the same composition with the copper oxide taken in the second experiment. If copper oxide having the same composition and they made by same element and they maintain a fixed ratio, then you can say that this problem, this reaction, this the copper oxide, the composition of copper oxide obey the law of definite proportion. From the problem, look at that. In the first experiment, here two methods are given and they are considered as the first experiment. Another is the considered as the second experiment. In the first experiment, weight of copper oxide is your how much? 1.375 gram. Weight of the copper is your how much? 1.098 gram. If I want to find the percentage of copper, then you can write here what? 1 point, look at that, 1.098. You can find the percentage like this, 1.098. This is the weight of copper. Percentage of copper means what? Weight of copper weight of copper divided by weight of copper oxide into 100. Here the weight of copper means how much? Here the weight of find, if you calculate, you will find percentage of copper is your 79.86. In copper oxide, two elements are present. One is copper, another is your oxygen. In case you can say that in copper oxide, here you can say that percentage of copper plus percentage of oxygen equal to 100, because here two elements are present. If the percentage of copper is your 70, able to find the percentage of oxygen, yes or no? That means here you can say that percentage of oxygen is equal to 100 minus 79.86. Look at that. Here I can write. Here I have written percentage of copper is your 79.86. Percentage of oxygen is your how much? 100 minus 79.86. That is your 20.14 percentage. That means in the first method, the copper oxide having percentage of copper is your 79.86 and percentage of oxygen is your 20.14 percentage. Now move to the second experiment. Here the weight of oxide is your 1.476 gram. Weight of copper is your 1.179 gram. Percentage of copper, again apply same concept. Percentage of copper means weight of copper divided by weight of copper oxide into 100. Here the weight of copper means 1.179 gram and weight of the copper oxide is your 1.476. So here I can write percentage of copper means 1.179 divided by 1.476 into 100. If you will solve this, you will able to find that is your 79.89. Now I will again apply the same concept. That percentage of oxygen is your how much? 100 minus percentage of copper, that is your 100 minus 79.89 is equal to 20.11. Look at that. If you think about the experiment 1, in this case, copper oxide, if I will think about the composition of copper oxide, percentage of copper is your how much? In the first experiment, percentage of copper is your 79.86. Percentage of oxygen is your how much? That is your 20.14. Now move to the experiment 2. In experiment, if you will think about the copper oxide used, if you will think about the percentage of copper and percentage of oxygen, percentage of copper is your 79.89. Your percentage of oxygen is your 20.11. Look at that. In the first experiment, copper oxide having 79. Second experiment, copper oxide having copper percentage is your 79.89. They are just nearly same to each other. You can say that they are similar to each other. They are approximately same to each other. If you think about percentage of oxygen in first experiment and compare with the percentage of oxygen in second experiment, look at that. In first experiment, percentage of oxygen is your 20.14. The second experiment, percentage of oxygen is your 20.11. They are just similar with each other. So if you think about in both experiment 1 and 2, you can say that copper oxide having the same composition, copper in oxide have the same composition made by two element copper and oxygen. They are made by a fixed proportion. Look at that. Here the percentage of copper and oxygen are similar with their corresponding other experiment. Since percentage composition of copper oxide in both experiment, look at that. Here copper oxide having same composition with experiment 2. So here we can say that since the percentage composition of copper oxide in both experiment is the same, the law of constant proportion is verified. Look at that. In problem number 1, there are two experiments. First experiment, second experiment. In the first experiment, copper oxide is used. In the second experiment, copper oxide is also used. The copper oxide used in the first experiment having same composition with the copper oxide used in the second experiment. Since the composition of copper oxide is same in both experiments, here we can say that law of constant proportion is verified. Next, move to the problem number 2. What happened? Look at that. If you think about the problem number 2, look at that here. 1.275 gram of magnesium oxide. Here magnesium oxide is taken MgO. Here also two experiment are given. In the first experiment, this is the first experiment. This is the second experiment. Here magnesium oxide is given. If you will, there are two experiment. The first experiment, and that is your first experiment. This is the second experiment. Here magnesium oxide is present. Here also magnesium oxide is present. If the percentage of magnesium is same with the percentage of magnesium, percentage of magnesium in magnesium oxide used in the second experiment is same. Simultaneously, if the percentage of oxygen and in first experiment, if simultaneously if the percentage of oxygen in first experiment is equal to the percentage of oxygen in the second experiment, then you can say that magnesium oxide have the definite composition, and here the law is verified. Let me explain. If you will read the question, 1.275 gram of magnesium oxide contain 0.7969 gram of magnesium. That means here I can write in the first experiment, mass of magnesium oxide is your how much? 1.275 gram. Mass of magnesium is your how much? 0.7769 gram. Then percentage of magnesium is your what? Weight of the magnesium divided by weight of the magnesium oxide. Here weight of the magnesium means 0.769. Weight of the magnesium oxide is your 1.275 gram. So here I can write percentage of magnesium is equal to 0.69. Sorry, here I can write percentage of magnesium is equal to 0.769 divided by 1.275 into 100. If you will solve this, then you will able to find 60.31%. Similarly, you can say that percentage of oxygen is your equal to how much? 100 minus 60.31. That is your 39.69. In the first experiment, percentage of magnesium is your 60.31. In the second experiment, percentage of in the first experiment, percentage of magnesium is equal to 60.31, and percentage of oxygen is your 39.69 percentage. Now move to the second experiment. Mass of magnesium oxide is your, if you will read the question, in the another experiment, 1.85 gram of magnesium oxide contain 1.116 gram of magnesium. So here I can write in the second experiment, mass of magnesium oxide is your 1.85 gram. Mass of magnesium is your 1.116 gram. Now find the percentage of magnesium. Percentage of magnesium is equal to weight of magnesium divided by weight of magnesium oxide. Your weight of magnesium is 1.116. Weight of the magnesium oxide is your 1.85 gram. So here I can say that percentage of magnesium is equal to 1.116 divided by 1.85. Now multiplied with 100, you will solve, then you can able to find 60.32 gram, 60.32 percentage. Similarly, you can find percentage of oxygen. Percentage of oxygen means 100 minus 60.32, that means 39.68. Look at that. If you will think about the first experiment, if you will think about the first experiment and second experiment. Now think about the magnesium oxide. In the first experiment, magnesium in the first experiment, magnesium. Sorry, again I want to. Sorry. In the first experiment, in magnesium oxide, magnesium percentage your how much? That is your 60.31 percentage. And percentage of oxygen is your how much? Percentage of oxygen is your 39.69. Similar thing about the second experiment. Think about the magnesium oxide. Magnesium percentage of magnesium is your how much? 60.32. Percentage of oxygen is your how much? 39.68. Now look at that. In first experiment, percentage of magnesium is nearly equal to with the percentage of magnesium in the second experiment. Similarly, if you think about the percentage of oxygen in first experiment must be nearly same with the percentage of oxygen in the second experiment. Here 39.68, here 39.69. They are just similar with each other. If you think about the magnesium, here 60.31, here 60.32. They are just similar with each other. Finally, you can say that the magnesium oxide used in the first experiment having the same composition with the magnesium oxide used in the second experiment. That means the composition of magnesium oxide in both experiment is the same. So the law of constant proportion is verified. In the first experiment belongs to copper oxide. First problem belongs to the copper oxide. Second problem belongs to the magnesium oxide. Next, move to the problem number 3. Here carbon dioxide is given. Here also two methods are given. Here also your target to verify law of definite proportion is proved or not. Your first experiment is given. In the first experiment, mass of, look at that question, 1.8 gram of carbon dioxide contains 0.491 gram of carbon. So here I can write mass of carbon dioxide is your 1.8 gram. Mass of carbon is your 0.491 gram. Next, move to the other part. In another experiment, 2.2 gram of carbon dioxide contain 0.6 gram of carbon. So here I can write mass of carbon dioxide is your 2.2. Mass of carbon is your 0.6. Now find out the percentage of carbon in the first experiment. Percentage of carbon. Your percentage of carbon means weight of carbon divided by weight of carbon dioxide. Similarly, percentage of oxygen means weight of oxygen divided by weight of carbon dioxide. You must multiply with 100. Here also 100. Again, I will repeat. Percentage of carbon means weight of carbon divided by weight of carbon dioxide into 100. Percentage of oxygen means weight of oxygen divided by weight of carbon dioxide into 100. Look at that. Percentage of carbon here is equal to weight of carbon means 0.491. So here I have written 0.491. Weight of carbon dioxide means 1.8. So here I have written 1.8. Now multiply with 100. So here I can say that percentage of carbon is equal to 0.491 divided by 1.8 into 100. If you will solve, then you will get 27.28. Similarly, percentage of oxygen means subtract the percentage of carbon from 100. Here I can say that percentage of oxygen is equal to 100 minus percentage of carbon. That is your 27.28. That means percentage of oxygen is equal to 100 minus 27.28. That is your equal to 72.72 percentage. If you think about the second experiment, apply the same formula, percentage of carbon and percentage of oxygen formula. Here we can say that percent of carbon is equal to 0.6 divided by 2.2 into 100. If you will solve, that will equal to 27.27. Similarly, percentage of oxygen is equal to 100 minus percentage of carbon, that is your 27.27. So percentage of oxygen is equal to 100 minus 27.27. If you will solve, that is your 72.73. Look at that. If you will think about both experiment, if you will think about the first experiment, think about the first experiment, think about the second experiment. In the first experiment, think about the carbon dioxide. Percentage of carbon is your 27.28. Percentage of oxygen is your 72.72. Similarly, think about the second experiment. Percentage of carbon is your 27.27. Percentage of oxygen is your 72.73. Your percentage of carbon is your 27.28. Your percentage of carbon is your 27.27. They are just similar with each other. Your percentage of oxygen is your 72.72. Your percentage of oxygen is your 72.73. They are also similar to each other. That means carbon dioxide used in the first experiment must have the same composition with the carbon dioxide used in the second experiment. Since the percentage composition of carbon dioxide in both experiment is the same, so the law of constant proportion is verified. Now move to the problem number 4. Here sulfur dioxide is given. You will prove like the problem number 1 and problem number 2. Let me explain. Look at that. Here also two experiment is given. First experiment and another is the second experiment. 2.55 gram of sulfur dioxide contain 1.275 gram of sulfur. So here in the first experiment I can write mass of sulfur dioxide is your 2.55. Mass of sulfur is your 1.275 gram. In the another experiment, 3.4 gram of sulfur dioxide contain 1.7 gram of sulfur. So in the second experiment, here I can write mass of sulfur dioxide is your 3.4. Mass of sulfur is your 1.7. Look at the first experiment. Here I can say that percentage of sulfur is your how much? Percentage of sulfur means weight of sulfur divided by weight of sulfur dioxide into 100. Similarly, percentage of oxygen, you can use this formula 100 minus percentage of sulfur, or you can apply this formula weight of oxygen divided by weight of sulfur dioxide into 100. As your choice, you apply this or this. I have applied in all the case this. Directly subtract the percentage of one element from 100, then you will able to find other element. Now look at the experiment 1. Your mass of sulfur dioxide is your 2.55 gram. Mass of sulfur is your 1.275 gram. So here I can set the percentage of sulfur is your 1.275 divided by 2.55 into 100. If you will solve, it is equal to 50%. Similarly, if you will think about percentage of oxygen, here you can you can subtract 100 minus 50, that is your 50%. Similarly, think about the second experiment. Your mass of sulfur dioxide is your 3.4. Mass of sulfur is your 1.7. Percentage of sulfur means 1.7 divided by 3.4 into 100. If we solve, then it is equal to 50. Similarly, percentage of oxygen means 100 minus 50, that is your 50. Now, let me conclude. If you will think about the first experiment, think about the second experiment also. Percentage of percentage of sulfur is your 50, percentage of oxygen is your 50. Here also percentage of sulfur is your 50, your percentage of oxygen is also 50. Look at that, your sulfur in the first experiment is equal to percentage sulfur in the second experiment. Similar thing about the percentage of oxygen in first experiment is equal to the percentage of oxygen in the second experiment. Here the sulfur dioxide having same composition used in first experiment and second experiment. Since the percentage composition of sulfur dioxide in both experiment is same, so the law of constant proportion is verified. Since the percentage of composition of sulfur dioxide in both experiment is same, so the law of constant proportion is verified. This is all about your law of definite proportion. That is your law of definite composition. You can say any word. Constant proportion, law of definite proportion, law of definite composition is your choice. You can call the law of definite proportion in any word. This is all about two law I have covered in this class. Two law. One is the law of conservation of mass. That is your first law. Law of conservation of mass. And I have also covered in this class law of definite proportion. In the next class, I will cover another law of multiple proportion. Another is law of reciprocal proportion, and another is law of gaseous volume. For this class, this is very sufficient. Thank you all for watching the YouTube video. An important point, if you want to note of every class, then you will go to the description. There is a link. You will click the link, then you will able to download the note of each class. Thank you. Have a nice day.